for the warm introduction, and good afternoon to all participants, and welcome to the webinar. My name is Ralf Feuerstein, and I'm part of the Delta European sales team, and in charge of AC/DC and DC/DC converter modules. Of this webinar today is honored DC/DC converters, but we will also have a brief view on the rest of our portfolio. Here in content, we'll talk about applications, basic knowledge, features and benefits, power architectures, form factors and options, reliability and quality, portfolio, and of course a short outlook about the new trends. I would like to give you a short introduction. A Taiwanese company with more than 70,000 employees and was founded in the year 1971. Ours is power supplies. In 2002, Delta is the world number one in power supply solutions. As you see here, our turnover is about $75 billion. We're manufacturing more than 25 million pieces power supplies per month. We have power range from 1 watt up to 10 megawatts. Big advantages and benefits for the customers is our high power density, and we're providing up to 98% efficiency for all solutions. We have around about 70,000 R&D engineers worldwide. 5 to 6% of our group sales revenue is going to the R&D department. Besides power supplies, we are also the number one world in DC brushless fans, also leading in telecom power systems, in industrial automation, renewable energy solutions such as PV inverters or wind or data center infrastructure, passive and magnetic components, and networking products. Here is our corporate mission. So we are to provide the highest innovative, clean, and energy efficient solutions for the tomorrow. As you see here, the stadium located in Taiwan, and this is also acting like a power plant, and of course a lot of energy and CO2 emission. On this you can see our locations. We have sales offices, we have 2 manufacturing sites, and 11 R&D centers. Our business units, we have 3. The power electronics, where we belong to with our embedded power supplies, and with energy management and smart green life. For electronics, you find less embedded power supplies, DC converters, vehicle power supplies, industrial power supplies, and fans and thermal management components. And management group, you see here industrial automation products, power systems, USs for data center infrastructure, electronics, and renewable energy. In the smart life, we have networking solutions, displays, electronics, and healthcare devices. And all brands called Energy, small adapters, and VVTech projectors. Into the first business unit, business group, we hear the embedded power supplies for server and PCs. Here our DC converters, the LED power supplies. We have also mobile adapters and here for the DIN rail and for the medical applications. Business, some examples for the other business group. For the systems is here the rectifiers for the telecom systems, indoor systems, UPS, also the renewable energy like the PV inverters and the wind turbine converters. Yeah. Now I'd like to go products, the embedded products, onboard DC-DC, AC-DC, and off-board AC-DC and DC-DC converters. So what you see here on the left side is for the PCB mounting on boards, and here frame converters, the encapsulated converters, so the AC-DC power supply for the PCB. We show our portfolio on the DC-DC and AC-DC module for DIN rail and level mount solutions, and you can see here this is a DC-DC IP67 product and also IP52 supplies for the end mount. Applications are designed for a wide range of applications and deployed in different market segments. This one market segment is industrial applications, so you find a lot of applications in this segment where we have the right products for. Then we have also we're providing products for the air, such as diagnostic studies, CT scan, and so on. Also, where the market for us is transportation, for dock in the infrastructure. Of course, we have a lot of telecom products in our portfolio for any kind of telecom applications. Now I want to talk a little bit about the basic knowledge. The focus is, of course, here DC-DC onboard modules. And on the following pages, I would like to introduce the most important characteristics of DC-DC converters. What is the purpose of a DC-DC converter? Well, the most common purpose for having a DC-DC converter is high bus voltage coming from power supply or the system, and you cannot. It's not possible to feed your electronics with this high bus voltage. So to convert it down, for example, to 5 volts, that your electronics can work with it. The reason to have a DC-DC converter is for safety reasons. Well, in some applications, it's necessary to galvanic isolation. This is especially in user interfaces where you can attach loads or sensors externally, and so you'll be on safe side and you need a galvanic isolation. The last reason having a DC-DC converter is to have the stabilized output, because for some reasons you have a battery as the input source, and the battery is fluctuating, sometimes charging, sometimes it's low. And so with a DC converter, you can stabilize this power, this output, and then it's usable for other electronic devices. You see here is a converter. So we have 2 big families in the DC-DC converters. We have first one is the isolated DC-DC converters. The principle is easy. On the primary circuit, you see a switch. So you simply convert the DC switch into an AC voltage. Then you have a transformer with a ratio, and on the outside you have a secondary circuit, and then you rectify your AC again to DC. So the most important part is, of course, the transformer. This is the reason why we call it isolated DC-DC converters. Because transformer, the output voltage is independent from the input voltage. Yeah, the family in DC-DC converters is non-isolated DC-DC converters. As you can see here, no transformer, no isolation. It's not necessary to have an isolation. You have already an isolated converters in the front. Using a non-isolated has some advantages because you have higher efficiency, much smaller in size, and also more cost-effective. For non-isolated DC converters, you find maybe buck converter is very usual, or step down is popular. We call it mostly point of load, or short POL. There's no galvanic isolation, and the output voltage is always smaller like the input voltage. Yeah, this is a little bit about the basics here of DC-DC converter. First, we want to look into the input of a DC-DC converter. So DC-DC converters need some external components to fulfill the requirements, and one of the requirements is EMI. You can hear a reference design for an EMI filter to meet class B of the EN50 and only a suggestion, of course, but we don't want to do it discrete. You can also choose one of our EMI filters. So the parts you see here for 5 to 20 amps, we have solutions for that. For reference, you find a PCB design proposal, which space you have to consider on your PCB board to the safe side later on. Please consider also some extra space for the X and Y capacitors that might help you later if you do the debug during the EMI test. Input cap, let's assume that we have a constant load. For whatever reasons, when the input voltage is increasing and we have a constant load, basically the input will drop. That here. The result is a converter shows a negative differential impedance. We need an input cap because we have a lot of inductors, like the wiring. Also, the power source is an ideal source because you have always some inductance, some impedance. Impedance becomes equal to the converter impedance, then your system becomes unstable. To that, you can add a capacitor, an input capacitor, very close to the input of the DC-DC, and this keeps your complete system stable. We quote values between 10 and 33 microfarad. Capacitor is the hold-up capacitor. So when you need voltage drops, this capacitor will help you to keep output stable for a certain time. Now, the formula when you want to calculate the value for the capacitor, for the hold-up capacitor. In case you need a reverse input protection, you can suggest you here. We would like to introduce 3 different solutions. So the first one is very easy, but also very effective. You have a fuse which blow when you connect, of course, the wrong polarity. This is, of course, you have to replace afterwards the fuse. But this is very effective there is no loss during operation. Of course, it's not maintenance-free and it's not reversible, so it's but it's a design and cheap solution. This is also very simple. It's just a diode which blocks the negative voltage, and this has, of course, a big disadvantage because you see a voltage drop across the diode. Will reduce the overall efficiency of your system. Is of course one with the biggest effort and also requires the most space on your board, but the losses are relatively small over the FET, and it's completely maintenance-free, and it's an active solution. After the input, we look at the output of a DC-DC converter, and one of the biggest issues always is how to measure the noise. Always a small AC portion caused by the switching frequency, and how to measure a small frequent signal. The best what you can do is to at least a 20 megahertz bandwidth oscilloscope, and what we recommend is not using the ground clip, because the ground clip could make an antenna and then use something which doesn't exist. Recommendable is using a BNC socket. Another output issue is the maximum output capacitance. You find this value in all our data sheets, and this is the maximum value for the output capacitance. Exceed this value, it happens that the very high peak current will activate the overcurrent protection. Because overcurrent protection prevents the DC-DC converter from a short circuit, and a very high peak like a short circuit. So please of the maximum capacitive load, and here you find, of course, you consider. Right. Just in case you need a higher output voltage, which is not available on the market, you can order DC-DC converters in series. By that, please be sure that you have a diode on each output to the startup of the module because of wrong polarity. When you need double power, when you need more power, you can consider a parallel connection. Basically, standard DC-DC converters should not be connected in parallel. The problem here is that the product, the DC converter with a slightly higher output voltage will provide the higher load. One with a slightly smaller voltage will deliver nothing. So there is no symmetry in the current share. There is no current share. When you try to adjust the output voltage, they are with identical models. When you try to adjust them and you fix the output voltage to the same level, then it will mean that a small drift in temperature or the output impedance will cause again unbalanced load sharing. So it's recommendable to do a parallel connection with standard DC-DC converters. What you can do, of course, is for redundancy reasons, you can parallel connections as long as each converter can deliver the total load. some diodes or O-ring MOSFETs, which prevents, in case of a short circuit, the bus voltage. So whenever there is a failure, you have a full redundancy diodes. There are some special inverters on the market which are dedicated to parallel connection. They are designed for that. Converters, they have either active current share, or they use the droop function. The droop can be used then in the connections necessary to exchange any data between the modules. Sorry, no necessary. They balanced by tolerance by 7%, and well, this will run over the characteristics, the output characteristics of the DC-DC converters. So they are limited in power. That means when one converter is delivering more current than the other, the output voltage goes immediately down, and this means the other one will be taking over. And the balance between those two over the output characteristics, so they let themselves. Here are some DC-DC converters and also power supplies which are using the drop current sharing or field current sharing with an interaction. I see the most important selection criteria. A few percent makes already a big difference. Efficient converter generates less heat, and the cooling for you is much easier to realize. Here's a very easy example of watt converter. The 100 watt is the output power. You need, of course, when you have some losses, when you have efficiency, you need the consumption is of course bigger. So for when you have a converter with 94% efficiency, you have 6.4 watts on the input, and that means you have 6.4 amps losses. And converter, you see you have 4.2 amps losses. So having 2% better efficiency makes already a 35% better better result on the power losses. And this is important because less heat dissipation, 5% less. Efficiency, you can save energy, reduce your cost, the complete total cost of ownership. The power losses, of course, by doing that, you can it reduces the heat dissipation and also extends the lifetime and increase your system reliability. Here we a quad with 600 watts, 12 volt, 50 amps. See here, because it's also very important at the efficiency curve. Most of the converters in the market, they have the highest efficiency at the maximum power, but as you know, no developer, no R&D engineer will address converter at the maximum power. So it's very important to have already the full efficiency, the highest efficiency, let's say between 60 or sometimes 70%, half load. So this is very important. Talking about cooling methods. So effective cooling is essential to avoid overheating, overheating, to ensure a long product lifetime. Here are different methods shown how to dissipate the heat. One forced cooling. So you have a system which provides an airflow. The conductor can be cooled down by the airflow. This is called conduction cooling. Conduction cooling is using your metal housing to dissipate the heat from the converter to your AC. Yeah? You can do that either using a thermal pad to touch the surface, the top side of the components of the converter, or there are also optional base plates, things available, which can also which better thermal behavior, and so you can dissipate heat over the base plate. But by the way, this is the most effective cooling. The last one is when you fan, when you have no housing, when you have just stationary air. Of course, the worst case for a converter, and so all the heat dissipation is on the surface of the converter. Yeah, that way the conduction cooling is the most efficient, and also water cooling is based on the same principle. Is also a combination of forced and conduction cooling. Induction cooling. When you want that induction cooling, you can use your pins around the input and the output to use the pins to dissipate your heat to the areas. When you pave large areas around those pins, these are acting like a heat sink. This is a clever method. We are carrying two equal converters in terms of size, with two completely different thermal behavior and performances. So looking at this one is a 2x1 product with 60 watts. On this curve, at 60 degrees Celsius ambient temperature, there is no derating. It starts at 60 degrees, so that means you get the full 5 amp, 100% of your power at 60 degrees Celsius. Yeah, and the derating starts later. It's completely different here. This is an 8-brick, 360 watts, means 6 times more power in the same, almost the same size. And you can see at 60 degrees, a natural convection, you get around about, I would say, 13 amps. Yeah, this is of course much more than this one, but it's only 30% of the maximum. So, maximum, you need additional cooling. There is no way. It was about let's say, the basic knowledge. Now I would like to introduce popular features and also the benefits. Popular options is the remote on-off. With the remote on-off, you can turn on and off your mode with the TTL signal. You have the choice for negative or positive logic. A very popular option, the trim function. With the trim, you can compensate losses in output wiring or in your distribution, and then increase you can increase the output voltage, or you can also, if you like, to decrease the output voltage to another way. Normally, you have a rate plus minus 10 for the trim. have also 20% and 50% of the nominal output voltages. Yeah, a very nice function which can help you to compensate your losses in the distribution when you have voltage drops in the distribution, or when what is the routing? Yeah, then you can use this function. This function compares the actual voltage on your load with the segment of the DC-DC converter. So the difference from this set, the output voltage to the actual voltage on the point of load. Yeah, and using a very short loop sense line, you can measure this difference, and then the converter regulates the output voltage. Yeah, this thing you have to be you have to consider to really avoid long here between the sense and load. Also, you should be careful the output power does not exceed the maximum rated power. Otherwise, there is no room for the regulation. You don't use this function way. It's better to short the output with the sense on each polarity. Then a lot of built connections in the DC-DC converters, which help you, of course, because you don't have to care about those features. These are the most common built-in protections. It's called the over voltage protection, the over current protection, and the over temperature protection. Whenever your output voltage exceeds the P set point, your converter will, for safety reasons, in the same if the output current exceed the OCP set point. So when it's down, it activates the hiccup mode. The hiccup mode means so there's a certain time and for recovery, and when your failure disappears, the converter starts. If the failure didn't disappear, it goes back again to the hiccup mode, and this happens and repeats until failure was found and the problem fixed. The auto restart. This is what I just explained. Another option is the latch mode. So wherever there is a failure and the hiccup mode is activated, it latches, and there is no auto restart here. So there's another protection called the over temperature protection. For any reasons, when you heat up the converter too much and you set it too much and the temperature exceeds the temperature of the hot spot, exceeds the set point, then the converter shuts down. To a certain time, when the value, when the temperature is below the OTP value, the converter starts again into normal operation. Yeah. Or it's always clever to use. It's only, of course, for the frame converters to use those hotspots shown in the data sheet, and then you can monitor the temperature of those hotspots and see if there are improvements for the cooling necessary or not. Here I introduce you with the planar winding technology. Before we do that, I would like to show you first a traditional transformer. A traditional transformer exists of the bobbin. Of course, because of the bobbin and the windings, and there is also a tape for the isolation, and around there is a plastic housing. This transformer will be soldered on the top side or the butt of the PCB, and it's hardly to imagine how to dissipate out of this transformer. But with a planar transformer, you will see the transformer. First, you see that the PCB is a PCB with 10 layers or more. And, the links of the transformer are embedded into the multi-layer PCB. And afterwards, you see the core is going through the PCB, and then it's very easy here to cool the surface of the core, and it's also possible to cool layers over the pins. So the pins, they like a heat sink, because you can cool down here, and they are connected thermally and physically to the windings. So this is a big advantage, and this is one of the reasons why our converters are a very good thermal performance. We're using, by the way, those technologies for all DC converters above 10 watts. Very technology here. Usually in a converter you have a transformer and you have an output inductor. It's physically here on the converter. So this is the transformer, this is the output inductor, and of course you have always these two magnetics. There is no way. We have a very innovative solution with delta magnetic integration technology. That means we combine both magnetics in only one. There's a lot of advantages because you have one magnetic in the converter, and this saves space on your board, and it also saves material costs. It's much easier to assemble in mass production, which reduces again your labor cost, and it's more efficient. So we can reduce the conduction losses, and this is reliability. The reason why our products are so competitive and also have such a nice thermal behavior. Yeah. By about thermal behavior components, but we also have some restrictions. As electrolyte capacitors and tantalum capacitors, they will have a negative impact on your lifetime and the thermal performance. This is one of the reasons Walter decided in 2006 to weigh those components. So you won't find any of those components in our DC-DC converters. It's another benefit for the customers on the market. You find many different form factors. You find many different pinnings. You find many different input voltages, and so we have here with 5 different form factors and 2 input voltage ranges. We can do almost everything on the market above. Yeah. You see, for example, these are very common input ranges. This is a 4x1 input range, 9 to 36 volt, which covers your 12 volt and a 24 volt input. Or this one is an 18 to 75, also 4 to 1 for 24 or 48 volt. Yeah. The output voltage, and this is only the maximum power. So there are a lot of products behind that. In a 16 brick, in a quarter brick part, and also by 1 in the 2x1 inches. talking about form factors and pinning, this is what you find on the market, 1x1 and a 2x1. It's very popular for between 10 and 20 watts. You find 2x1 reserve, and of 30 watts up to 60 watts you find 2x1 inch solutions. The pinning is always different. Yeah, and this is makes a lot of confusion in the market. We have consolidated all these form factors to 2 versions, offering a 1x1 and 2x1 package. With these 2 input ranges, you can cover almost every request on in the market. Those converters up to 60 watts. Applications. Performance. Here we are doing a comparison between a 1x1 and 2 competitors. Where we competitors, not cheap ones, really quality products, and they have the same package, by the way. It's a 15-watt converter with different output voltages, 9 to 36 volt input. And see here is that we hit all competitors with the efficiency, and also thermal behavior is so much better because our rating starts here at 77 degrees Celsius ambient, and the competitors already at 60 degrees ambient temperature. It's, by the way, the same for the 20 watts. The only difference here is we still using a 1 product. The competitors, they by 1. Even when they have double size, the efficiency is less than ours, and also our rating starts 5 degrees Celsius later than the competitor. The last comparison is for the third. You won't be surprised. It's here exactly the same situation. So we have a 1x1 compared to a 2x1 from the competitor. Here the difference is not that much big, but you see still the efficiency is better, so much better. This is, of course, a big benefit for you using those products. Now a little bit about power architectures. There are different architectures, popular architectures in the market. One common is a conversion. Then normally for the input you have an AC/DC power supply. This one, by the way, is an external one. So this is directly providing the 24 volt for drive or valve, and also providing the input voltage for the DC. The first choice here is an isolated because this power supply is external, so for safety reasons it's better to have isolated converters, transformer, and that can generate from the 24 volt to 12 volt for a display, for example, and from 24 to 5 volt for your electronics. This is very common and called voltage conversion. There's a conversion which you see here. It's much bigger. This is very popular when you need lots and lots of output voltage with very low but very high current. This is very popular in the telecom, in the data center, and so on. Again, in the input, you have a big power system. It's nothing else than a power supply providing 24 or 48 volts. You have also in some systems for data centers you find even higher voltages, 400 volt, for example. We have also solutions for that. Your meter is less, and also the current is lower. But here we have a 24, 48 volt bus, a battery backup, with the backplanes. The voltage, the power to the board. We have then 24, 48 volt. This is to a much too big bus voltage. So what we are doing here on the board, we have introduced an IBC converter. IBC, intermediate bus converter, has a wide input range, for example, and the output is 12 volt. 12 volt, this is very usual because the point of load is working with a 12 volt input. So this converter is the only reason for this converter is to feed the point of loads. This is called the 12 volt bus is called the intermediate bus. The points, they are non-isolated, they have very high efficiency, they're small, very cost effective, and when this architecture is a solution. You see, for example, 3.3 volt, 2.5, 1.8. This is not, in some applications, you see even 1.5, 1.2, or 1.0 volt, and those currents, they can go up to 100 amp. Here, a comparison between a double conversion and a single conversion. The conversion, of course, to add efficiency, to multiply efficiency of each converter. Here is the IBC with 9% converting from 48 to 12. And then you have the point of load converting from 12 to 1.8 with efficiency of 88. So the total efficiency at 1.8 volt is 84%. This is not bad, but of course, when you do a one-stage conversion, you can have an improvement of 4 to 6% efficiency, as you can see here, with a direct conversion. Yeah, it's high. Which one is the better, the single or the double? It depends really from case to case. The requirements in the market are so different. It's always worth to think about both solutions and come to a conclusion later on. Now, on the next pages, I would like to show you the most form factors and all those mounting options. On the right, you see the PCB mount, the onboard modules, the encapsulated ones in the open frame, the bricks, and the external power supplies for the mount, for the DIN rail. We have also AC/DC and DC/DC solutions here, and they're also IP protected. So here, first we start with the encapsulated onboard modules. On the left side are the DC/DC, popular single inline package, inline package, SMD package, the 1x1 and the 2x1, which I introduced already. So you see those converters, they providing a range from 1 to 6 watts with up to 6 kilovolt isolation. You find many different input ranges, different outputs, single dual outputs. 1 and the 2x1 goes from 10 to 60 watts with a 4 input, 12 and 24 volts, and you find different output voltage, single dual output, and you get optional heatsink for the cooling. DC onboard modules, also very interesting product. Power supply on board on your PCB. It provides isolation up to 4 kilovolts, from 10 to 60 watts. All they have wide input range. They also class B filter all built in, so you don't need any external components to the N55 or 22 class B. Also, you find a lot of output voltage, single, dual, triple outputs, and this one is the AB series. It is certificated the medical norm, the EN60 also applicated for applications for need a MOPP protection, that means of patient protection, which find in some medical applications level. Talking about onboard modules, here we see the open frame, or what we call bricks. It's in the 1990s which is here with a full brick, and afterwards we always cut the size by half, and so we have a half brick. Again, the quarter brick, an 8th brick, 16th, and 32nd brick. These are very popular formats in the market. By the galvanic isolation up to 2,250 volts. There's big power here, starting the smallest one from 25 watts up to quarter brick and a half brick with 600 watts. Now this is a big power T for such small size. Our big advantages, of course. So the voltage goes here is 4x1 from 1875, which can also be used for industrial applications, where usually a 24 volt input voltage is dedicated main telecom power, and this input voltage is for railway, for 110 volt railway applications. You find here output voltage is between 1 and 50 volt output only. Open frame, if you need a conformal coating, that's also available as an option. Converters encapsulated. As an option, you get an SMD pinning, optional heat sink for the conduction cooling. Open is an external now. We talked previously about the onboard modules. Now we talk about the external ones. Here for the DC-DC, we have an IP67 product. Was originally developed for a forklift truck, but now we found many different also applications for this one. Power is 300 watts. It has very wide input range, so it doesn't matter if you have a 24, 48, or 72 battery. So here with this wide input range, you connect each you want, and there is also a filter and a protection included. There is also here a fuse which can replace when it's blown up. So options you will see later on. I will explain this product later again. DC offboard modules. We have also DIN rail and chassis mount. They are 52 protected. It's a simple product like the onboard modules with those mounting options. But it starts from 15 watts. So below 15 watts, we have solutions here. Again, the wide input range, the Class B filter included, big output range. Again, here this medical products with 60601 and WPP. Here on this page, we use an overview of all criteria to select the right product. So here with applications, industrial, telecom, medical, railway, transport applications. Of course, those applications require different norm. One of the most common is, of course, the safety norm, the 6950. Then the EMC norms, the medical railway norm, transportation norms. It also depends, your selection also depends on the environmental, the indoor application where you see maybe dust, outdoor application where you have vibrations, humidity, or high temperature. It's also, this leads to the case. The case is of course important. Do engl encapsulated version, or is an open frame suitable? Also the option to coat those open frames, the conformal coating. And then, of course, you have the ones for outside applications with IP52, IP67, and even IP68 we have in our program. Then for the isolation, do I need an isolation? Do I need a high voltage isolation for medical, for example, or reinforced isolation? And again, the double MOPP, or is it all sufficient to use a non-isolated product? I have already in front an isolation. Yeah. Let's see here the different form factors: single inline, dual inline package, the one on the bricks, ports, an integrated point of load looks like an IC, type converters. Here, different power ranges, different input voltage ranges, of single, dual, triple outputs, different output voltages, different cooling like the forced one, like the convection cooled or suction cooled. Then you can consider the best choice for the cooling and the derating, and also be aware of the efficiency. Then here the mounting options, whether onboard module or a panel mount, a DIN rail, and you have also here for the point of loads, you have an option for horizontal or vertical mounting. Of course, the vertical needs less space on your PCB. This is about options. Very popular remote, the SMD. If you need SMD package, no problem. This is an option for the brick, for the single inline and dual inline package. Here we only for the dual. We have the trim here, the trim option, the sense line option, EMI filter, the share, and this is something I will explain later. The PM bus. It's the digital bus, full control of your converter. Techniques. Now I would like to talk a little bit about reliability, quality. Of course, focus is always the customer satisfaction. We have many different tentative and always the first priority the customer's requirement and the customer satisfaction. So, reliability, what we committed, and we always try to improve ourselves. Here you see, by the way, on the top side, you see here our factory in Bangkok. Here you see also the certifications for this factory. Products are manufactured here. We have in Bangkok round about 12,000 employees, and the products are developed here in this R&D center in Shanghai. Quality management. The quality delta starts not manufacturing. It starts already when we do the design, when we start the R&D. Talk a little bit later on the next page about this one. What they're doing during the design, the design phase. Also, supplier quality assurance. We do monthly quality audits. We have performance ratings. We have first in, first out control. For the manufacturing, we have sampling tests. We do a 100% functional test for all products which are leaving our factory. We do a test for the isolation, a visual inspection. Our products are burned in afterwards. For the quality, we have a shop floor system, so we do a barcode scan after each work step. In case that you have in the field later on a failure, we have ARM A process, and we do a failure analysis, a root cause, and so on and so on. This is what I was mentioning before. We have, during the design process, we have a lot of tests. We do some functional tests to see if the specification is okay, if the characteristics are aligned with specification, protection of if protections or isolation efficient, and so on and so on. Also doing a lot of environmental tests with mechanical shock, with vibration, cycling tests, temperature, humidity, drift. Then here is all about safety. The most important norm is, of course, the UL-EN 6955. And we have also for some products a CE mark. Then we have time tests of MTBF calculations. We're doing also stress analysis tests, design margin tests, also this high acceleration lifetime test, which is a big effort. Here we go beyond the specification of the product and see what is the weak point, and then we fix it. Talk about our portfolio on the high runners. So industrial for the encapsulated, the single line, we have dual inline package, SMD package, size, with many different options. And between 10 watts, we have the 1x1 package with 36-volt input, and for the 2, we have 40 and 60 watts, 9 to 36-volt input, and many part numbers with many different output voltages, and so on and so on. Yeah, that was about encapsulated DC-DC. Now we're talking about the open frame or brick converters. We have water brick up to 600 watts, 8 brick up to 360 watts. The 6 brick goes up to 100 watts, and here's a second brick with 25 watts. This is a range, of course, from 25 to 600 watts. Where you see here different input voltage ranges. The 4x1, the narrow input for data center applications with efficiency. The big advantage and the benefit for you is you have such a big high power density in those products and very high efficiency, and very cost effective. Let's talk a little bit about the non-isolated point of loads. You see here this is very popular, the DOSA 1, the DOSA 2. See products here up to 30 amps. We have also introduced now a new digital PO with 12 amps. This one has a PM bus. Power blocks, very small product with very high current. They did up to 80, new up to 100 amps. Small size, very compact. And then we have the integrated poles. They look like an IC, for example, with 3 or 10 amps. This is for consumer products. Yeah, already we have products also for healthcare applications. They are certified by the 60601. Some DC-DC converters, and here are some AC-DC converters, and also this one have also the MOPP. Here are a lot of railway applications, for example, door control. We see cabin equipment. We see passenger information here. We see lightning applications, wireless, motor and drive control. Also a vigilance system. So this is all about rolling stock, but we have also the products for the rolling stock. They are EN 50, 155 certified. This is this one for the 110 volt, goes up to 20 watts. Here we see again the 1x1 and the 2x1 for local trains having 24 volt. Yeah. Of course, this is all for rolling stock. We have also a lot of for the infrastructure. I already introduced a little bit earlier. It's a 300 watt proof DC-DC converter, which was designed for forklift trucks. And meantime, we have many different other applications like caddies, like electrical cars on airports, and so on and so on. So this one is IP67 protected, a very wide input range, can be connected to the battery. It has all protections and so on, filters included. 3 different output voltages available: 12 volt, 30.8, and 24. I have also 3 different input ranges. This is with a wide input, this is with low input, and this is another one for only high input range. Then you see the different options here. CD option. This means there's a fuse holder, there's an enable pin, and so on. This is a cable outlet here. It's also waterproof, the connector, but you can attach any kind of connector. Yeah. So about box type here, also standard AC/DC power modules, power supply, which you can either PCB or the external ones for the chassis mount in the D-rail. Power range goes from 2 watts up to 60 watts. You have single, dual, triple outputs. Yeah, what I already mentioned. You have already a Class B filter included, so you don't need any extra filters. Also fulfills a lot of norms and standards. Look a little bit into the future. What are the trends? But first, we want to look in the history. In the past, we saw here the development of the efficiency. In 2000, in the year 2000, we saw the efficiency was 92%, and it was growing up now over the last years up to 6% now. We have products above 96% isolation, and so the power density increased a lot. So, and this is still the trend. So efficiency is really one of the key elements, and there is no end here. So we will introduce new technologies like full digital control converters with high very efficiency, and there is no end. Not yet. Then talking about the digital control, let's say first a power supply, a DC converter was fully controlled. Now with new technologies, we have introduced some full digital converters. You see that they are already in the market, and this is a quarter brick, for example, goes up to 600 watts fully digital. This is brick goes up to 360 watts fully digital, and the POL with 25 amps. And all these converters, because they are digital controlled, it's easy, of course, to implement a serial bus. We call this bus PM bus, yeah, but it's nothing else than an I2C serial bus. So the power management is very easy. It's very common, this bus, and with this bus you have full control of your converter. You can store, for example, the temperature of the converter. You can also monitor the input voltage, the input current, also the output voltage, output current, or also adjust the output voltage at a certain level, so that you have always the same product, and you just program it, and then you can output voltage. You can when you fixed, yeah, or can do it in the application online with us. This is one of a really nice feature, very useful. Yeah. Now we're coming already to the end. So when you have questions, please don't hesitate to contact us. We have a team which can help you for any kind of technical questions with application notes, with EMI filter recommendations. Also can do thermal simulations for you. We have also application boards if you need them. If you help, please contact first. This was it from my side. I would like to thank you for your participation and your interest, and I hope you find it a little bit interesting. And I want to say goodbye and give the word to back to Mrs. Schmidt. Thank you.
Yes, thank you. A nice presentation. There are no questions in line.
Okay.
If you have any questions, please ask them in question and answer tool. We will be here 5 minutes. The recording of this webinar will be on our homepage, conrad.biz, in a few days. And now, have a nice day, and we will hear us soon.
Bye.